Hi folks, we're going to take a look at number 6 on page 301. So in this question, they give us this equation which represents the height of a ball kicked from a height of 0.5 meters above the ground. Okay, and D is the horizontal distance that it travels, and H is the height above the ground. All right, so here question 8 asks, how far has a soccer ball traveled horizontally to the nearest tenth of a meter when it lands on the ground? Okay, so if you're not sure how to solve these, this has a physical significance. So you can draw yourself a picture. Okay, so the ball is kicked, so it's going to go up and it's going to come down. Okay, so if we want the horizontal distance that it's traveled when it's at the ground, well, you realize that that's just about finding the x-intercept. Okay, now we also anticipate there being a second x-intercept on the negative side, but we're not going to be interested in that one. Okay, so if I'm looking for the x-intercept, it means I'm replacing h by 0. So 0 equals negative 0.1 d squared plus d plus 0.5. Okay, so now we have a few ways of determining the solution to this equation. I could factor, although I don't really feel like doing that with decimals in there. I could complete the square and then solve the equation. That's a very long process, but now we have a much quicker way of doing it. We can use a quadratic formula. Okay, now in particular, the equation is already in the correct form to use a quadratic formula. So as we're going to see in B, it's very important that it's in the correct form before I try to apply that formula. In other words, ax squared plus bx plus c equals 0. Okay, so here, when you're starting to use the quadratic formula, you might want to specifically say what a is. So a is negative 0.1, b is, well, what's the coefficient of d here? It's just 1, and then c is equal to 0.5. And then from here, you put this into the equation. Now, because the x variable is actually a d, you should be using that here. So it's negative b, so negative 1 plus or minus the square root of b squared, so 1 squared minus 4 times a, negative 0.1 times c, 0.5, all over 2a, so 2 times negative 0.1. Okay, and because it's a context question, they even tell us the expectation is that you're approximating this. Okay, but what I'm going to suggest you do is you simplify it a little first, and then put the whole thing inside the square root. In the calculator. Okay, so let's work here. So what do we have? I'm going to start by simplifying what's in the square root. So we've got 1 squared, which is 1, minus 4 times negative 0.1 times 0.5. Make sure you're getting the signs in correctly. So we got negative 1 plus or minus square root of 1.2 all over, and 2 times negative 0.1 is negative 0.2. Okay, and I would say from this expression here that you should now stick that in the calculator to approximate. Okay, so we have negative 1 plus square root of 1.2. Okay, I would press equals here, because remember, if you just do divided by negative 0.2, you get the wrong answer. You'd have to first put brackets around it. Okay, so I didn't do that, so I'm just going to calculate the whole numerator, and then now I'm going to divide negative 0.2. So you got to make sure you consider bedmass. So here we have negative 0.48. Okay, is one of the answers, so approximately negative 0.48. And now let's put in the other one. So the other one is going to be negative 1 minus square root of 1.2 equals, and then divided by negative 0.2, and 10.48. All right, so you notice here, the other thing you could do is also approximate square root of 1.2, but then, you're just getting a less accurate answer. So you might as well do as little approximating as possible. All right, so now that we found our x-intercepts, we have to look at what we're actually interested in. So we're looking at the horizontal distance that it hits the ground. I'm not interested in the negative 0.8. I want to see you still find it, but now you can give the answer, and the answer is at D, which represents the horizontal distance, equals 10.48 meters. All right, so let's take a look at part B now. So part B tells you that they're interested in the horizontal distance when the height is 2.6 meters. So I'm just going to replace the height by 2.6 meters. So 2.6 is equal to negative 0.1 d squared plus d plus 0.5. And I again have a quadratic equation. However, it's not quite in the form that I need in order to use the quadratic formula. Okay, so step number 1 is to take everything to one side, so I've got 0 on the other side of the equation. All right, so here I think just to make things a little simpler, I'm going to bring everything to the left-hand side. So it's negative 0.1 d squared. When I bring it to the other side, is going to become positive, so 0.1 d squared. This plus d is going to become minus d. And then here 2.6 minus 0.5 is 2.1, and then I'm left with 0 on the other side. So make sure you clearly indicate that you've gotten to 0 on the other side. Now I've got the form that I need where I can use a quadratic formula. So now I can just stick everything into my equation. So it's negative b, so negative 1, okay, plus or minus square root of negative 1 squared minus 4 times a, which is 0.1, times c, which is 2.1, okay, all over 2 times a, which is 0.1. All right, so again, let me simplify a little, and then we'll worry about finding our approximations. Okay, so here we're just going to have positive 1 plus or minus square root of, so let's determine what this is. So negative 1 squared is just 1 minus 4 times 0.1 times 2.1, and that's a 0.16. Actually, that looks like it's a perfect square. Okay, and this is going to be 2 times 0.1 is 0.2. Okay, in fact, we can check here. Take the square root of 0.1, oops, wrong thing, square root of 0.16, and hey, it's a perfect square. Okay, so here what we're going to do to find our answers is going to be 1 plus 0.4 equals, and then divided by 0.2. Okay, so 7, or, and then we'll do 1 minus 0.4 equals, whoops, must have done something wrong, 1 minus so I keep getting the wrong thing, 1 minus 0.4 equals, and then divided by 0.2 is equal to 3. Okay, so notice here we have 2 positive answers. Okay, so does that make sense? But again, if you look at your diagram, I guess the maximum, we didn't find the maximum here, but it must be larger than 2.6. So if 2.6 is somewhere here, it's not surprising that it's at a height of 2.6 at 2 different locations. Okay, so here we would say at d equals 3 meters and d equals 7 meters. This is when it's at a height of 2.6 meters. All right, so just to recap here, we started off with a quadratic function, okay, but because we were then replacing h by particular values, in the first scenario by 0, in the second scenario by 2.6, we were able to create quadratic equations. And the way we solve quadratic equations is with the quadratic formula. However, we can only do that when it's in the right format. In this case here, it was already in the right format. In the second scenario, we had to do a little algebra to put it in the correct form, ax squared plus bx plus c equals 0. Okay, that's it for this one.